Alright, this is the first video for Chapter 1. This is Chapter 1, Section 1, Understanding Points, Lines, and Planes. So the objective for Section 1 is to identify, name, and draw points, lines, segments, rays, and planes, and to be able to apply basic facts about points, lines, and planes. These are some of the words that you are going to be learning in this section. You have two options for this. One is to write down all of the words now, leaving about 4 lines blank per one. Or what I would do is go ahead and as we go through the notes, you're going to discover the words and then just write the words down when you get to them. So I'm going to be doing that. So the first part we need to look at is the most basic figures in geometry are undefined terms. This will be our first vocab word we write down. And next to it, we're going to write what a undefined term is. Undefined terms are point, a line, or a plane. You cannot define them in the real world. You cannot draw a point. A point is a so tiny thing that you can't even see it. But we're going to use a point to example what a point would be. So that'll kind of make more sense as we go along. So we're going to be drawing basic figures to symbolize them. All right, our next word is point, and this is also going to be our first buzzword of the semester. Every time we do notes, we're going to have a buzzword category. You can either write these all at the top of the section, at the end of your notes, towards the side and the margin. It does not matter. I do want all buzzwords together. Buzzwords are what you'll be graded on partly for your notes. So the first one is going to be point. So write buzzwords. You're going to have 3 buzzwords for this section of notes. First one is going to be point. You're going to be drawing this, or you're going to be writing out everything in this. If you want to do this in a table form like they do in the notes, that's fine. Otherwise, you can just list them as a typical notes vocab type of thing. So the first one is going to be a point. It names a location and has no size. It is represented by a dot. When we name it, we're going to use a capital letter. For the diagram, we're going to be using P. So for this example, I just wrote P. So next, we're going to write diagram, and we're going to show when we see a point what it's going to look like on a problem, test, quiz, or homework. When you just see a point with a capital letter next to it, a little dot, that is a point. That one's pretty simple. Next one is line. A line is a straight path that has no thickness and extends forever. We're going to be naming this with a lowercase letter in cursive or 2 points on the line. So if you notice, there are 2 ways to name this, either XY or YX. So over here in the diagram, you see XY and YX on this line. So you can name it in any order with the arrows above it. So if you're going to use the cursive, you just use the lowercase cursive letter. This is called line L. If you're going to use the points, you're going to call it XY. You're going to put a line above it. Make sure you draw the arrows above it. If you don't draw the arrows, that does not signify that it's a line. A line extends forever. So those are what those arrows are symbolizing, that it extends forever. A plane is a flat surface that has no thickness, and again, it extends forever. So over here in our diagram, it is an example of something that we can symbolize a plane. A plane is a undrawable object. It's going to extend forever. You can't draw a plane. So this is a symbol of a plane. Same as this is a symbol of a line and a symbol of a point. A point, a line, and a plane, there are no actual things that are those, so you have to draw a symbolized picture. So to name it, in the bottom left corner in this diagram, they have a cursive letter R in blue. Or they call it script. That capital cursive R is the name of the plane, kind of like how we had the lowercase cursive L for the line. So a lowercase cursive can represent a plane, or a line, and a capital cursive is going to example a plane. Or you can use 3 of the points that do not form a straight line and call those by the plane. So plane R or plane ABC. Either one is correct. So the next word for you is collinear. Points that lie on the same line are collinear. So if you're looking down at this line, we've got point K, point L, and point M. And down here is point N. Please draw this diagram in your notes. This goes along with the definition. So points K, L, and M are collinear because they lie on the same line. They connect a straight line when I connect all three. K, L, and N are non-collinear. So because K, L, and M form a straight line, they are collinear. Because K, L, and N do not form a straight line connecting it, they are non-collinear. Okay, your next buzzword for this section is coplanar. C-O-P-L-A-N-A-R. Coplanar. Points that lie on the same plane are coplanar. Otherwise, they are non-coplanar. We'll see some examples of those here in a minute. So for the first example we have, they want us to give this diagram and they want us to name what they're asking for. So to your best of your ability, draw this figure in your notes. Under the last part we did was coplanar. You're going to draw this with example 1 next to it. So go ahead and draw this down, and then we're going to do step A. Step A asks us to name 4 coplanar points. So if I look at this diagram, I see one plane here, this bottom plane, a plane that kind of forms a triangle here, another plane that forms a triangle, another plane that forms this triangle on the side, and then on the back side of this pyramid is another plane. So 4 coplanar points. The only plane that has 4 points is this bottom square. So I'm just going to name those 4 points. A, B, C, and D. Next I'm going to do B. Name 3 lines. Move this up out of the way so I have more room to write. I can pick any 3 lines I choose, lines that have the arrows on the end of it. So the first one I'm going to pick is A, and I'm going to see where that point goes to, where this line starts. So it goes to A, this line goes all the way up to E, so next I'm going to write the E next to AE, and I'm going to draw this line with arrows above it. Again, with a pencil you'll be able to draw this a little more neatly, hopefully. All right, next I need 2 more, so now I'm going to pick B. Again, it meets up at E. So draw the arrow lines above it. And last, CE. Again, you could have also chose DE. DE is another line. Any 4 of those lines would be good. Next one. Just go ahead and draw that yellow 4-sided shape and that pink triangle shape. Notice how the triangle has arrows continuing on and the 4-sided figure does not. So they want us to use the diagram to name the 2 planes. I accidentally forgot to take away the answer, so it's already there. Use the diagram to name 2 planes. So one plane is this yellow one. We can call this plane R, or another thing we could call the yellow one is plane KLM. All right, and then the other plane, ABC, is this pink triangle here. These 3 points form a plane. So you could call it plane ABC, plane BCA, CBA. It doesn't matter which order. The textbook and I are often going to put them in alphabetical order, so you're just going to see plane ABC written down. All right, the next definition is going to be segment, or often called a line segment. This is part of a line consisting of 2 points and all the points in between them. To name them, we are going to use the 2 letters that form the endpoints with a line above it without the arrows. A line segment does not continue on, so you don't draw the arrows when you label this. So these are the two ways that we could name it, AB or BA. You could do the first one you see on the left and then the right, or the right then the left. It does not matter as long as it does not have the arrows on the line. So over here is a diagram of what a line segment would look like. An endpoint is a point at one end of a segment or the starting point of a ray. Down below we'll explain what ray is, so let's just worry about endpoint right now. When we label an endpoint, we're just going to use a capital letter, not cursive like we do on a plane, just a capital regular letter. So over here on the diagram, C and D are the two endpoints. It's just the points that are at the end of a line segment. All right, the third one, a ray. A ray is a part of a line that starts at an endpoint and extends forever in one direction. So go ahead and look over here at the diagram first. Notice how this ray, it starts at a point and continues on with the arrow. So down here, now this ray is going the opposite way. It starts at R and goes through S and it continues on. That arrow tells us that line continues forever and ever. So when we name it, notice how they put R first and then S. Since they put R first, they're going to basically just draw a little ray over the two letters. And notice how they don't have an arrow over the R and they have the arrow over the S. So if you think about it, when you name it, you just draw the two letters and then draw which way the ray goes above those letters. Now for opposite rays. Opposite rays are two rays that have a common endpoint and form a line. So the common endpoint and any other point on each ray. So over here in the diagram, this red E going off to the blue G, this is one ray. So E to G is one ray. E to F is another ray. So there's two rays in this diagram. And because they both go in the opposite direction and they form that straight line, they're called opposite rays. Again, you're going to name it the same way that you did as a ray. You're going to put the E first, then the F with the arrow over the F. For EG ray, you're going to do the E first, then the G with the arrow over the G. So for example 3, they want us to draw and label. Draw and label each of the following. For A, they want to draw a segment with endpoints M and N. So first what I'll need to draw is a segment. So let me draw a segment first. And they want me to have endpoints M and N. So then I'm just going to put my M here and my N there. And so this is a segment with endpoints M and N. So for B, I have opposite rays with a common endpoint T. So first I'm going to draw my ray, what's going to symbolize my ray. So here in the middle I've got a endpoint, common endpoint T. And since it's an opposite ray, it starts at T, it's going to extend out this way, and it's going to extend out this way. So this would be an example of an opposite ray with common endpoint T. Another way, if you drew your ray this way, this is correct as well as diagonal. Rays do not have to go horizontally, vertically. They can go any and all ways. All right, now they want me to draw and label a ray with endpoint M that contains N. So this is example 4 in our notes. First, I'm going to draw my line. The endpoint is M, so this is the point that comes with the dot. So this is going to be M. The ray is going to continue out this way, so I draw the arrows. And it contains a point N, so somewhere on this line, there's going to be a point N. So that's all you would do for this one. So here is the next definition. The word is postulate. This is our last and final buzzword of this section. So at this point, you should have a buzzword section either at the beginning of your notes, in the margins, or if you're saving it for the end. And this will be the third one, postulate. So a postulate is an axiom. It's a statement that is accepted as true without proof. Postulates about points, lines, and planes help describe geometric properties. We'll get into that here in just a minute. So what a postulate does is we're going to be getting into proofs in the next chapter. A postulate is something that you can write down and you don't have to explain it. You could, so for example, 1 plus 1 is 2. 1 plus 1 equals 2. Everybody knows that 1 plus 1 equals 2 is true. You don't have to go up and say, prove this to me. So that's an example of what a postulate could be. So the first one is 1-1-1. The reason that the book and myself will name these postulate 1-1-1 is nobody has gone in and given this a name. There's no geometric name for this. It's not like the Mr. Anderson postulate. It's just there's no name for it. Somebody has already proven these, some Aristotle, Pythagoras, those old guys that have proven geometry for us. This is already proven, they just never named it. So whatever book you're using, this signifies the chapter 1, section 1, and it's the first postulate of this chapter section. So down here, 1-1-3, this is the third postulate of section 1 in chapter 1 of this book. So don't get too caught up on these names. We will put these in our notes so we can verify them later. So the first one is 1-1-1. Through any 2 points, there is exactly one line. So if you think about this, draw 2 points on your paper and use your pencil to connect them. There is no other way your paper can lie on your paper, or pencil can lie on your paper, except for one way. And that one way is the line that connects your 2 dots. So 1, 1, 2, through any 3 non-collinear points, there's exactly one plane containing them. So between these 3 points, this blue plane contains all 3 points. So that's just saying you draw 3 dots on your paper. Those 3 dots are in a plane. Your paper can be seen as that plane. 1, 1, 3. If 2 points lie in a plane, then the line containing those points lies in the plane. So think about, here's the purple plane. There's 2 points on this plane. Now up here, since 2 points form a line, those 2 points in this plane, that line is also in this plane. So that kind of makes sense. All right, now it wants us to name a line that passes through 2 points. So this is the diagram that they're giving us. Name a line that passes through 2 points. So I see the line here. It has 2 points, X and Y, so we're good so far. But I don't see a lowercase cursive letter that names this line. So I'm going to have to use the points of the line to name it. So I've got X and Y. I've got my line above it with the arrows to signify that it's a line and not a segment. So this is all you would have to do for this one. Next is wants us to name a plane that contains 3 non-collinear points. So this orange rectangle looking box, this is the plane. And this is 3 non-collinear points, F, G, and H. So they want us to name it. Again, there are 2 options for this one. Because of this cursive R in the top corner, this names this orange square. Everything in this orange square is in this plane R. So you can say plane cursive letter R, or you could say plane F, G, H. So the first way uses the cursive letter. The second way uses the 3 points in the plane. And again, I just went alphabetical order. You could have said plane GFH or HGF. It does not matter. Okay, so recall that a system of equations is a set of 2 or more equations containing 2 or more of the same variables. So this is kind of like your systems of equations that we did in Algebra 1, where you're solving for 1x, you're solving for an x and a y. The coordinates of the solution of the system satisfy all the equations in the system. So in your system of equations, you found your x and you found your y, and that worked for both. So those coordinates lie on a graph of the equations in the system intersect. So in geometry, an intersection is the set of all points that 2 or more figures have in common. So this next one isn't really a definition, but I would write the word intersection down. and then write set of all points that two or more figures have in common. So the next two postulates will help describe intersections. So an intersection of two lines, there's one intersection right there. We're going to see how planes can intersect and how multiple lines can intersect. So postulate 114, if two lines intersect, they intersect in exactly one point. So next to this postulate, I would draw an example of two lines intersecting at one point. If you want to label that point, you can. I'll go ahead and label it P for point. So an intersection of two lines, you can use the point of your pencil to find where they intersect. 115 is if two planes intersect, then they intersect in exactly one line. So let me draw an example of a plane. So here's a horizontal plane, we'll call it L. And then think of this vertical plane. And these two are going to intersect right here. That's the intersection of these two lines, or these two planes. And that forms a line. All of those points combined together form a line. So if two planes intersect, then they intersect in exactly one line. So this is that line where they intersect. So when we're drawing these figures in geometry, we're going to use a dashed line to show the hidden parts of any figure that you are drawing. A dashed line will indicate the part of the figure that is not seen. So for example, this part does not need to be in your notes. If I'm going to draw a dice, you're going to draw first the square. So let's call this the 1. And then this is the top of the dice, 2. And then down here, there's a 3. So if you're looking straight on, all you see is these three sides. But if I'm being true to what a dice is, I need to show, for geometry's sakes, those other three sides that we can't see. So we're going to use this dotted line to show that. So you can kind of see by adding those dotted lines, you can see a little better. Of course, I messed that up a little bit, but you can see where those now all 6 sides are. So notice in this one, you can see the 6 sides. 1, 2, 3, 4, the 4 sides, the top, and the base. Over here, you only see the 1, 2, and 3. So make sure when you're drawing planes, and later on when we get to other three-dimensional stuff, you're showing those dotted lines. All right, so our last example is to draw things on our own. So 7, they want us to sketch 2 lines intersecting in exactly one point. So this one we already did in our notes. So 2 lines, here's one with my arrows, and they want to intersect at one point. So there we go. There's no other way to draw this than that. And let's go ahead and show where the point is. Next, they want us to sketch a figure that shows a line that lies in a plane. So what I'm always going to do, if I'm going to be drawing a plane, I'm going to draw that first. And now sketch a figure that shows a line that lies in a plane. So here's my plane. Now I just need to show that the line lies on it. So that would be simple enough. All right. So for our last one, example 8. Sketch a figure that shows 2 lines intersect in one point in a plane, but only one of these lines lies in the plane. So let me show you what the problem is with when you don't draw your plane first. So let's go ahead and first address the 2 lines intersect in one point. So I could show this, and then I want to draw it in a plane. Well, here's my plane. But notice what this last part says, but only one of the lines lies in the plane. So, this isn't going to work. So I'm going to go ahead and squeeze this out of the way so I can draw a better example. So let me draw my plane first. and I'm going to draw one of the lines that lie in the plane. So this lies on the plane. So imagine that the room that you're in, the plane represents the floor, and we've just drawn a line on your floor. So now I want this line to be intersected though, but it can't lie on the floor as well. So imagine you put this line going through the center of the room, going straight down through the room. It goes straight down through the room. This dotted line shows the part that you can't see, and then it comes out the other end. So this is how I would draw a line intersecting a plane that you can't see the bottom part of it. So that would be the last example. And so that finishes it for chapter 1.1.